This topic started off looking at sources of lights and reflectors. Sources make light. That would be things like light bulbs, the sun, TV, torches. Reflectors don't make light. Light bounces off them, and that would be things like mirrors, reflective strips on jackets, bike reflectors, the moon, or cats' or dogs' eyes. Then we went on to look at light travelling in straight lines, and we used a laser to show that. Unlike in Star Wars, you can't see the laser unless it hits something, so a surface or water droplets, and they also don't make a pew-pew noise. We found the law of reflection, so the angle of incidence is equal to the angle of reflection. Remember, we don't measure the angle to the mirror, we measure the angle to a line at right angles to it, which we call the normal. Then we looked at refraction. Refraction, this is when light changes speeds moving from air to glass or glass to air. It also happens when it moves from water or other transparent substances. And this makes the light change direction. As with reflection, we measure the refraction to a line at right angles to the surface, which we call the normal again. Moving from air to glass, the light bends towards the normal, and moving glass to air, it bends away from the normal. We learned there are two types of lens, convex and concave. Convex is thick in the middle and brings light beams together. Concave is thin in the middle and spreads light beams apart. We looked at eyes, and we found that they have a cornea, a pupil and a lens, which lets in the right amount of light and focuses it on the retina, which is the light sensitive part of the eye. Sometimes this doesn't work properly and we need to use another lens to fix it. If the light is focused too far in front of the retina, then we need to spread it out a little, so it focuses on the right part of the retina. If it's focusing behind the retina, then we need to converge it. We found that a prism can split white light into the colours it's made of, which is all the colours in the rainbow, and something like Roy G. Biv or Richard of York gained battled in vain can help you remember the order of the colours. We also found that mixing the primary colours of red, green and blue can give us all the other colours. A TV or a phone screen has red, green and blue dots, which can be turned on or off to give us all the colours. Finally, we found out that if we take something that's red, like a red rose or some other object that's red, and we only shine blue light on it, so we take it into a darkened space and we only shine blue light on it, it's going to look black because a red object doesn't reflect any blue light. It absorbs all of it, so a red thing will look black. Then you had to know about all the different colour mixings, things that would get you the next colours, which were yellow and magenta and cyan. And you had to understand how things would look that colour, what colours they would reflect and what colours they would absorb. And that's pretty much optics.